Okay, hi everyone, hi again. In this second video, we're going to go through the second set of the revision. So this is a revision test 2. Okay, so let's jump right in. Let's take a look at question 1 right away. Okay, so binomial expansion, so you need to expand, okay, in ascending powers of x. So expand, just expand. And how many terms we get? We need first 3 terms, right? So when we expand, let's make full use of the first 3 terms and we see what turns up from that. Okay, so I will have a plus x times a 1 minus 3x to the power of n. Okay, so what are we expanding? Are we expanding the first one? Not entirely, but we're expanding this, right? So this is the one that we're expanding. So I'm just going to write a plus x here first. Okay, I'm just going to write this over here first, right? Then the next would be the expansion, right? So over here, same thing, same strategy. I'm just going to use the same strategy for all. So this is n choose r, so n choose r, right? So I will leave this blank first. So a and b, a n minus something, and then I have a b of the r. Okay, so let me copy and paste this thing first, right? So that is easier lah. Copy, paste. So 1, 2, 3, 3 terms, right? We don't need so many terms. We just need the first 3 terms. Okay, because we need to do until this b square will do. Okay, so n choose 0, n minus 0 and 0. R is 1, R is 1, R is 1, R is 2, R is 2, R is 2. Okay, do you see this? Okay, so how do we write everything nicely? So now this will become a plus x, right? Okay, n choose 0 is 1, 1 to the power of anything is 1, negative 3x to the power of 0 is 1. N choose 1 is n, 1 to the power of anything is 1, negative 3x power 1 will be negative 3x. N choose 2 will be the special result n minus 1 over 2, 1 to the power of anything is 1, negative 3x choose negative 3x2 will be 9x squared positive. Okay, like that. Okay, next let us do this. So we have a plus x. Okay, simplify. 1 minus 3n of x plus 9n n minus 1 over 2 of x squared, and so on and so forth. Okay, then because we need to compare this, right? So means we need to do another round of expansion. So over here I will have a minus 3na or 3a_n_x plus 9a_n_n minus 1 over 2 x squared. Okay, so this would be the first line. Second line would be plus x minus 3n x squared, okay, and then plus and so on, because I don't need the x cube term, so I don't need to expand the last one. Okay, and you know why I write this? Why I write like this is because, okay, so the first one is just this, this and this, right? The second one will be just this, this and this, right? But the second one, these two will give me the x cube term, so I don't need to expand this. I'll expand these two will do. Okay, and why do I write this? So that this is all my constant term, all my x term, all my y term, right? So then I can adjust and, like, solve this easier already. So comparing terms, okay, so comparing each terms, right? So for the first one, a is actually equals to 2. Okay, second one, negative 3an plus 1 is going to be equals to negative 17. Okay, so what does it means? This one, x equals to negative 17x. So the coefficient negative 3an plus 1 is equals to negative 17. Okay, so then we know a is 2, right? So I have a negative 6n is equals to negative 18. N would be equals to 3. Wow, so small. So n equals to 3. Sure. Okay, next one, the last one over here, it is this is plus b, right? So b is going to be equals to these two added up together, right? So b is going to be equals to 9a n minus 1 over 2 minus 3n. Okay, so let's sub all these values in. So 9, 2, 3, 3 minus 1 is 2 over 2 minus 3 times 2. And sorry, n is 3, so 3 times 3. Okay, cancel. So 2 is 2, these 2 can cancel. I'm going to have a 9 times 18, wait, 27 times 2, 54 minus 9. So this will give me 45. Okay, so 3 values A, B, and N like that. Okay, oh, okay, I was blocking this, apologies. Okay, so one more time, we can, yeah, sub all the numbers and we can cancel these two things all together. Okay, so we can do this to get our 45. Okay, so this is question 1. Okay, question 2. So what is actually question 2? We expand this one power 11 in descending powers of x. So like I think by now you can roughly see a trend. So over here, okay, so if you see this one over here, if you want to expand in ascending powers of x, the x is placed at the back of the bracket. Okay, so that this power over here will increase, ascending power of x, right? Okay, now next, if you want to expand in descending powers of x, this x term will be placed in front. Okay, and because the power is actually decreasing for a. Okay, so let's see how this works again. So expand in descending powers of x would be this, and then I'm supposed to look for h and k. Okay, sure. Let's do this. Okay, so I have a 2x minus 1 over 8 to the power of 11, right? Power of 11. So this one would be just the general formula but repeated, right? So n is 11, r I don't know yet, and then I have a to the power of n minus r, and I have a negative 1 over 8 to the power of r. Okay, so how many terms am I expanding? 4 terms. So 1, 2, 3, 4. Let me put one more down here. And then, yeah, so 4 terms can. Okay, so let's do something like this. And let's fill in the blanks with the r. So r is 0, r is 1, r is 2, and r is 3, and so on and so forth. Okay, so let's, oh, not 4, 3. Okay, so let's simplify. Okay, alright, so let's continue from this one over here. Okay, so let's use our calculator to do some okay, so 11 choose 0 is 1. Then I have a 2 to the power of 11, x power 11, right? So 2x power 11 will be 211 x 11, right? Using the law of indices. Next one would be negative, anything power 0 would be 1, right? Okay, using our calculator, 11 choose 1 is 11. Now, then this one over here, power 10. So 2x power 10 whole thing. So it'll be 2 power 10 x power 10. Okay, and then we have a negative 1 over 8 also. Okay, next one, 11 choose 2 would be 55. Okay, 11 choose 2 would be 55. So this one over here, this is power 9. So this will become 2 power 9 x power 9, right? And this one over here, 1 over 8 square, negative would be 1 over 64. Negative, negative, positive, right? Last but not least, okay, let me add. Now 11 choose 3. So this is 165. Over here, this one over here, 11 minus 3 is 8, right? So this would be 2 power 8 x 8. And then this one will be negative 1 over 8 whole thing cubed. I will leave it like this first. Okay, dot dot dot, and so on. Okay, now, so next I'm going to simplify everything. So 1 times 2 power 11. So this one, the first one will be 205 1.48x11. Okay, next one, 11 times 2 power 10 times negative 1 over 8. So this would be minus 1408 x power 10. Just nice. Okay, then the next one. The next one is this one over here. 55 times 2 to the power 9 divided by 64. So this will give me 440. So 440x9. Right? Now next one, okay, let me plus. Okay, so 165 times 2 to the power of 8, then times negative 1 over 8 cubed times, why do I plus? Okay, so this will be minus 165 over 2 x power 8. Okay, so it's fine for us to have a fraction as a coefficient. Okay, so therefore if you compare, h, right, is the, okay, over here, h and k, h is the coefficient of x9, k is the coefficient of x8, so these two are the coefficients that we want. So h would be 440, k would be negative 165 over 2, right? So hence number 2, find the coefficient of x9 in this expansion. So we have this power 11, okay, and we have a 2x minus 3. Okay, so the first one over here, 2x power 11, right, I can write it as 2, the one above, right, this one minus 1048x10 plus 440x9 minus 165 over 2 x8, and so on and so forth, right, to multiply to this. Okay, now here I'm looking for x to the power of 9, the coefficient of x to the power of 9. So how should I expand to get the x power 9? So for example, what should I expand with 2x to get my x power 9? This one over here. Okay, so technically this one will give me x power 9. You see, x times x8 will give me x9. Okay, next one. What should I expand from here to get my x power 9? Over here, x9. So a constant term and x power 9 will give me the x power 9 term also. Okay, so with this one, right, we don't need to write more. We don't need to expand the whole thing. We just put coefficient of x power 9. So this will be equals to 440 times negative 3 minus 165 over 2 times 2. So, okay, so negative 1485. Okay, so the answer for part 2 will be negative 1485. So here, now let me talk to you about binomial theorem again. Is that you need to keep repeating the process. You need to keep trying, and the best thing you need to do for yourself is to know when to use the general formula and how do you use the general formula for the binomial theorem. Okay, when it is expansion, it should look like an expansion. When you're looking for a specific term, then you just use a specific term. Now, for this question, can you look for a specific term? Can. You can zoom in to look for x9 and x8. X power 9, x power 8. So you find the r, then you find the coefficient of h and k. Also can. But for me, this question just nice because it's just expanding 4 terms. So it's just nice. Okay, I don't need to expand too much. Let's say if I want something in the middle, no choice, I need to use general term. Okay, so this is question 2. Okay, question 2. Hopefully this is okay. Okay, so question 3. So obtain the first 4 terms in the expansion of that. So if you know what to do, okay, straight away your answer would be something like this. 5, choose 2. Okay, like this. Okay, so you can arrive at this straight away if you know how to do this. Okay, now let's say if you don't know how to do this, so what can you do? By making use of the formula, rinse and repeat. Okay, over here n is 5, right? A is 1, and then n minus r, then have a minus p to the power of r. Okay, so I need to expand the first 4 terms, so I'm just going to copy and paste 4 times. Okay, so the process is the same. Okay, the process is always the same. Okay, so we just need to add in the fillers. Okay, and then okay, so let's start. So row from 0, so r is 0, r is 1, r is 2, and r is 3. Okay, so let's do this. 5 choose 0 is 1, 1 to anything is 1, negative anything power 0 is 1. Okay, 5 choose 1 is 5, 1 to power anything is 1, and then I have a negative p power 1. 5 choose 2 is 10, 1 to power anything is 10, then this will be p squared. 5 choose 3 is 10, 1 to power anything is 1, then negative p cubed would be negative p cubed over here. So this would be 1 minus 5p plus 10p squared minus 10p cubed, and so on and so forth. They only want the first 4 terms, so I will just give them the first 4 terms. Okay, so it's either you can write this straight away or you can do the steps one by one, up to you. Okay, there's no difference in the marks anyway. Okay, hence find the coefficient of x cubed in the expansion of this. So when we expand this, okay, when we expand this, so what happens over here is that p is this, right? So let me write it in a very nice form over here, because this is a minus p, so I actually need to write it as a 1 minus something. Okay, so that it's easier for me to sub p. So what is this something over here? This is x plus 2x squared. Okay, so that when we open up the bracket, right, it will be minus x minus 2x squared, and it's still in the form of this. So this will be our p. Okay, this would be our p. So over here, substitute p to be equals to x plus 2x squared. So over here, I will get a 1 minus 5p plus 10p squared minus 10p cubed. Okay, and what is the p? The p is this, x plus 2x squared, x plus 2x squared, x plus 2x squared. Okay, and then dot 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 and so on. Okay, so let's expand. So 1 minus, wait, we just need to find the coefficient of x cubed. Okay, sure. Okay, so let's expand now. So 5x minus 10x squared, right? Okay, plus 10. Okay, let's expand this. So I will have an x squared, right, plus 2ab, so 4x cubed. B squared would be 4x power 4. Okay, next one, 10, I have a 10, okay, x cubed plus 3a squared b. So I have a 3 times 2, it will be 6. 3a squared b, so 6x 4. And then the next 3ab squared would be 6x 5, right? Okay, plus 2 cubed, 8x squared cubed would be x power 6, like that. Okay, so this is how we get the next part. Okay, so let's expand. So where is our x cubed term? Because we only want the x cubed term, right? So do we need to expand again? Don't need. We only need this expand. Okay, and we only need this expand. Okay, so no, there's no other x cubed term. Okay, can. So coefficient of x cubed is going to be equals to 40, right, minus 10. So this is going to be equals to 30 over here. Okay, so yeah, so there you go. Coefficient of x cubed in the expansion of the new expansion. Okay, so one thing to take note, yeah, be careful of this. Your algebra must be you need to be sensitive to this kind of algebra. Okay, because I want to minus p the whole thing. So this whole thing I need to form a bracket, right? And be careful of the p. Okay, like that. Okay, question 4. So question 4 is given that 2 to the power of x minus 2 times 3 to the power of x squared is equal to 6 to the power of 2x. So show that 6 to the power of x is 2 and 1/4. Okay, so means we need to do something, right? We need to do something over here. Okay, so how do we do the something here is that now we are given this condition, we need to massage this equation and to form this. One more time, we are given this equation over here, we need to massage this equation such that we'll form this one as the final answer. Okay, so this will guide us for our final answer. So what can we do for this? So this is an indices question. So what can we do? Now, so the clue over here, right, is actually you have a 6 to the power 2x as the first clue. The second clue is that the answer wants us to have a 6 as a base. And just nice at the left, we have a 2 and a 3 as a base. So technically speaking, we can combine them together to form a common base, right? We can combine them together to form one base. 2 and 3, it will be 6. So what should we do? We will need to split things up before we combine together. So the first one over here will be 2 to the power of x over 2 square, right? Minus will be over, right? Times 3 to the power of x plus 2, so means times 3 square. Okay, so we need to split these out first. Okay, so that we can group all the things that we are supposed to group together. So what can we group together? Over here, this one together, 2 to the power of x times 3 to the power of x. Because of same index, the base can combine. So over here, this one over here, I have a 6 to the power of x times 9, right? Times 9 divided by 4. So this will be 6 to the power of 2x. Okay, now then last but not least, right, I'm looking for 6 to the power of x, right? So how do I get to 6 to the power of x would be, I just divide by this, right? So what I do over here is just to divide the whole thing by 6 to the power of x. So on the left, when I divide, the whole thing divided by 6 power x would be just this, right? So this would be just 9 over 4. On the right hand side, divide by 6 power x, right? So this would be 6 power 2x divided by 6 power x. If you use law of indices, 6 power 2x minus x will be 6 power x on the right over here. Okay? Or you can just cancel this and cancel the 2. Also can, if you can see it right away. So therefore, 6 to the power of x is 9 over 4, which is 2 and 1/4 shown. Easy peasy. Okay? Okay, so let me rephrase a bit now, or more like let me repeat a bit. So for this step, right, the clue is that you have a 6x right at the end for answer, right? And in the question, you have a 2x and a 3x, right? So the thing is you need to get them to multiply each other so that you can get your 6x. So that's the strategy that we are looking for this question. Okay? Okay, so once again, we are skipping question 5 and we're jumping right into question 6. So question 6 is logarithms. So given that log a x is p, log a y is q, express each of the following in terms of p and q. So for these kind of questions over here, we need to make sure that our base is always the base that is given to us like this. Okay, so unless there's p and q over here, right, we don't need the p and q. We want in terms of p and q as the answer. So we want to replace all the x and y and a in terms of p and q. Can, no problem. Okay, so how do we do this? Now, first question, the first one, log x base xy equals to a, right? So how should we do this is, over here the base given is a, right? So let's change everything to base a. Or if you know the shortcut, it is like this. Okay, so on top will be log AA, below will be log xy, log base a of xy. Okay, then what do I have here? 1 over, okay, so log base a of x plus log base a of y, using the product rule. And here, log base a of x is p, log base a of y is q. So my final answer will be 1 over p plus q. Okay, so my final answer is only in terms of P and Q and don't have X, don't have Y. Okay, next one. Part 2. Part 2, we talk about log base y of a x squared y cubed. So what we can do is that same thing. We can change this to log a. So on top, I'm going to have a log base a of a x squared y cubed. At the bottom, I'm going to have log base a of y. Okay, so on top, because it's a product, a x squared y cubed, so let's split them up. So I have a log a plus 2. Or wait, if you want, we need to go a bit slower. So log base a of x squared plus log base a of y cubed. Okay, at the bottom will be log base a of y. Now, log base a of a, this one is going to be 1. Okay, so I have a 1 plus 2 log base a of x plus 3 log base a of y. Okay, then divide. Okay, divide by log base a of y. So now we sub in. So 1 plus 2p, right? Log base a is p. Then 3q log base ay is q, and then log base ay is q again, like this. So there it will go. There is our final answer right there. Okay, so it's just replacing all the y, a, and x to p and q only. Okay, so it depends. Sometimes you may need to edit this to sub into your questions. Okay, question 7. Solve the following simultaneous equation. So what am I going to do is I'm going to let like the log 1 equals to 1. So because everything is written together, right? So you have the liberty to choose. But it's easier, like the easiest way to choose would be this, right? And this. Okay, usually I don't like to write times because it looks like X. So usually I use dot, but some people like misinterpret as decimal point. But anyway, okay, back to this. Okay, so we can split the equation over here into two parts. So this is equals to 1, right? This is also equals to 1. So then I can write it as two separate equations, because if I write this equals to this, it's going to give me headache, right? So might as well I just equals to 1 to make my life easier. So the first one is this log base 3 of x minus y is 1. Now, if you were to write this, right, I will need to slap you already because tell you cannot. This is not a quotient. The rule is called quotient rule. It's called quotient rule for a reason, not a difference rule. You cannot distribute the log base 3 like that because it's not a times. It's a function. So you cannot do the like times inside. Okay? So it's, don't think of it as time, think of it as a function. So when you do a function, then yeah. Okay, so what can you do instead is we can throw the 3 away, because 3 is the base for the logarithm. When we move to the right, the 3 becomes a new base. So this will be x minus y is equals to base 3 to the power of 1. So it just equals to 3. Okay, so this one, x will be equals to 3 plus y. So this will be my equation 1. Okay, so don't panic. You need to also know how to convert between index form and logarithm form, like this. Okay, like this, must know. Okay, so this is the basic skill. Okay, next one, let's look at the right hand side. Right hand side with 5, 25, 125. The strategy again is common base, right? So let's write this as 5 power x. 25, I'll write this as 5 square. 125, I'll write this as 5 cube is equals to 1. So let's add everything together. So 5 to the power of x plus 2y plus 3. Now 1 would be 5 to the power of 0, common base, right? So over here, comparing indices, so x plus 2y plus 3 equals to 0. So this will be my equation 2. Okay, so I will sub equation 1 sub into equation 2. So make sure you label. So I have a x plus 2y plus 3 equals to 0. X is 3 plus y. So over here I have a 3y plus 6 equals to 0. Y equals to negative 2. Then because of this, from equation 1, right, x will be equals to 3 plus negative 2 will be equals to 1, like that. Okay, so this is how we solve simultaneous equation with indices or logarithms. The only like new flavor, it would be just the logarithm change. Okay, so there's a logarithm and indices, then you need to filter out the x and y, or get rid of the logarithm or get rid of the index. Okay. Okay, question 8. Now, question 8, logarithm. Nice. So let us look at how to logarithm our way out. So we have a ln 3x plus 4 is equals to 1.3 plus ln of x plus 1. So the strategy for solving logarithm, same thing, common base, common index, right? So on the left, I have only one logarithm. On the right, I need to make sure that I can combine them into one logarithm and to throw them out. So what can I do over here? Okay, on the left will stay the same. On the right, this would be ln e to the power of 1.3. Okay, so you can write it like this, plus ln of x plus 1. Okay, so next what we can do is, now we can have a ln of 3x plus 4. So this is going to be ln of, now e 1.3 times x plus 1 from the product rule. Okay, then we can remove the logarithm together, so 3x plus 4 is equals to e of power 1.3, and then I have an x plus 1. So this is actually a number, so we don't need to worry too much about this. So my 3x plus 4 will be equals to e to the power 1.3x. Okay, plus e to the power 1.3. We multiply in for these two terms. Okay, so what we can do is to reshuffle around. So 3x minus e to the power 1.3 x times x is going to be equals to e 1.3 plus 4. Okay, so means x would be this. Okay, so let's convert to a fraction. Okay, and last but not least, calculator to evaluate your answer. 1.3. Oh, this is tedious. Okay, so I'm getting negative 11.5 over here for this answer. Okay? Okay, apologies. It seems that I have made an error. So the error is actually over here. -4, -4, -4. So my answer, okay, 0.494. Okay, 3SF. Just nice. Okay, apologies earlier. Okay, so let's take a look at B. Right, B, I'm going to have a e to the power of 2x plus 1 minus e to the power of x plus 1 equals to 30e. So the thing about this one, right, is that okay, I think we have, like, by now, if you've seen too much, right, anything has the power of 2x and x in the same place, right, means that most likely we're going to look at a quadratic equation. But before that happens, because they are all having a common factor e, so why not we just divide by e first? So if you divide by e for the first one, it will be e to the power 2x. Divide by e means I minus 1 for the power. E to the power x plus 1 will be just e power x minus 1 with the minus 1 power. Then this will be 30 divided by e, like that. Okay, so then what to substitute u to be equals to e power x. So the first one will be u squared minus u equals to 30. Okay, then we can solve for this, right? We can solve for this to be 0. So most likely it's 6 and 5, minus and plus. So u equals to 6 or u equals to 5. Then we match it back. So u equals negative 5. Okay, so we match back. So e to the power of x is equals to 6. So x will be equals to ln 6, which is a valid value. Okay, next one, u is -5. So e power x is equals to -5, right? Then x is equals to ln of -5. But the thing is, you've never heard of ln of -5 before because it is not defined. Okay, so actually there will be no solution for here. Okay, so means we reject this option. Okay, there is no solution because now e to the power of something, right, is an exponential graph like this. It doesn't go below the x-axis, so there's no value where it would be equals to -5. Okay, so this would be question 8. Okay, second last question. So question 9, find the value of p such that this. Okay, so I need to solve for p, right? So let's do some solving. So LG, or more I call it log. Okay, I like to write in cursive, so yeah, don't mind me. So LG of 2, 5, 6 over y plus 5 LG of y minus p log py, right? Okay, so let's make use of laws of logarithm to help us a bit. Okay, so for this one, I'm going to split them out. So I'm going to log 256 minus log y, right? Plus 5 log y, right? I'm just going to put is log y to the power of 5. Eh, wait, shouldn't. I should keep it as 5 log y first. Later I will see. Yep. Then I have a p log py, right? So most likely it will be a log py to the power of p. Okay, then maybe we'll solve for p later. Okay, so let's do this. So LG of 256, don't know yet. Find the value of p. Okay, so LG of 256 we don't know yet, so I'm just going to leave it there. Right? Then I have a LGY plus 5 LGY, so this will be a plus 4 LGY will be equals to LG of py to the power of p. Okay? Now, last but not least, this 4. Okay, I'm going to make this 4 go up. So using the laws of logarithm again, so plus log y to the power of 4. Okay, so I think at this rate, right, I need to be a bit sensitive, and I think I need to, like, you know, like, because now there's log on both sides, right, so I need to try to remove the log on both sides and see. So before that, I'm going to have a 256y power 4 goes to log of py to the power of p. Okay, so it's time to get rid of the logarithm. So therefore 256y power 4 is equals to py to the power of p, right? Or more like if you want to write it out, so this is p to the power of p and y to the power of p. So therefore p, the value of p is equals to 4. By comparing coefficients, the p will be equals to 4. Okay? Can so by comparing coefficients like this, okay, and also through this. Okay, so something like that. Okay, alright, so this is question 9. Okay, last one. So draw the graph of y equals to ln of x. Okay, so same thing, same request. Right, same thing, same request. Okay, sure, I'll give it to them. Okay, so this is 1, x and y. So y equals to ln x. Okay, can. So by drawing a suitable, by 2.5. Okay, so this would be 2.5, then this would be until here. Okay, I didn't take this point, so I will be open circle. Okay, so by drawing a suitable straight line on the line, find the solution of this. So x squared e to the power of x minus 2 equals to 1. Now this thing over here, right, is a ln x. Okay, over here, this thing here is a ln x. So technically speaking, right, what I can do is I can introduce the logarithm ln to both sides of the equation, and we'll see how that works out. So ln 1. Okay, so let's try this. So I have a ln x squared plus ln of a e x minus 2. So this will be equals to ln 1 would be 0. Okay, so this is some facts that you know ln 1 equals 0. Okay, next. Ln x squared. So this is going to be 2 ln x, right? So then plus, this would be just x minus 2. This is equals to 0. Then I replace this ln x with y. So now I have a 2y, okay, plus x minus 2. Because I've drawn this up already, I draw this already, okay, equals to 0. So 2y is equals to 2 minus x. So y will be equals to 1 minus x over 2, right? So means that what is this equation that I need to draw is a negative gradient graph cutting through at 1. Okay. So this one over here would be k. This over here would be 1. Okay. Let's find the x-intercept. So when y equals to 0, half x equals to 1, x equals to 2. Okay, sure. So means this line over here, okay, a bit weird, so means I change the line a bit. Okay, so this point over here is going to be 2. Okay, so let me tell you first, this point over here is going to be 2. Okay, can okay, so let's erase this. Okay, so the equation that we need to draw is this. Okay, we need to draw is this, y equals to 1 minus half x. So where is the solution? The solution would be here. Okay, so that's all for this lesson. Okay, so that's pretty much it for today. Alright, so hope you enjoyed the video. Hope it'll be clearer, and you need to replicate some of this thinking and some of this to verbalize your thinking in front of your friends soon. Okay, so yeah, hope it helped and hope that yeah, you had a better day ahead. Okay, alright, that's all for the day. Bye bye. See you in class tomorrow.